Good evening, guys. In last session, we discussed about regular relationship. Regular relationship is nothing but whenever there is a straight direct relationship between the master table and the transaction table in SQL Server. In other words, we can say it as foreign key related. When this is your, let's say this is your master table in database and this is your transaction table, and if it is having direct relationship using foreign key constraint, then we use regular relationship type in SSAS. So using this transaction table, what we will do? We'll create a fact table. We'll design a measure group here in the queue. And using this master table, we'll create a dimension. And the relationship between these two should be set, and the same relationship we call it as regular relationship. And if you see the properties, what needs to be set as part of this regular relationship, it's pretty straightforward one. You have to select the regular relationship here, regular type, and what is the granularity? Granularity in the sense, what is the least level in your master? In other words, what will be the least level in any master table? Obviously, the primary key column. Granularity in the sense, the least level or the leaf level of the table. Okay, what is the column based on which you can uniquely identify the data? If you see product key, that will not be duplicated. That means uniqueness. You are providing uniqueness to the product. So this granularity attribute will talk about the same. The 99.9999% cases, it will be the primary key of the dimension table. So I select primary key, automatically the dimension table will get filled here, the column. And what is the common column that is available in your transaction table to join these two tables? Or in other words, what is the foreign key column in your transaction table? It is product key, selected, click on OK, that's it. The relationship will be set. Now, this is, I hope you are clear up to this point. Now we are going to discuss about the second type of relationship, that is fact relationship. In fact, this is third type. The first type is no relationship, second type is regular, and third type is fact relationship. What is meant by fact relationship? Sorry. When the dimension table and the measure group table are same, then we call it as fact relationship. I told you an example that is color wise products. How many products are there per color in the product table? In that case, both dimension table and the transaction table are same, right? Let me demonstrate. Let me write the query in SQL Server, then you will get clear picture how this one will be related. First, let me show you the query for regular relationship type. Select star from dim product. This is my dimension table. Okay, I am aliasing it as a inner join. This inner join part, what we are calling it as relationships in SSAS. Fact internet sales. This is my transaction table, and hence I created a measure group using this table. B on A dot product key is equal to B dot product key. This product key is nothing but the granularity attribute, the least level which is used to join these two tables. This is for regular relationship. Now let's see how the fact relationship will be given in SQL Server. As you know, fact relationship is nothing but when the dimension table and the fact table are same, then the fact relationship will come into picture. And I showed you an example, right? Select color, comma, count of star as, I'll give alias name as number of products from dim product, group by color. So if you see, this count of star is gonna be my metric. Okay, the color is gonna be my attribute, dimension attribute. So the dimension attribute is coming from dim product table. The measure group measure, which I'm gonna use as metric to say which color is performing good, I'm gonna get it from the same table. So when the dimension table and the fact table are same, then that kind of relationship is called as regular relationship. And if you see, this is how you write query in SQL Server to achieve the fact relationship type. Now let's see how to do the same in SSAS. What is the first requirement here? What is the first thing I have to do to achieve the output what I'm showing here? If I execute this, I'll get some output, right? This output is my requirement. I have to show these color-wise products to the business. What are the steps that I have to follow? What is the first and foremost thing that I have to do? So as you said, it's not the count that needs to be added first. The first thing is attribute. First, what we're doing as part of the design. What we're gonna design the dimension or measure group. The first one is dimension design. So attribute is part of dimension design. So first you have to go for color. Whether color is there available or not, you have to check that. And if you see the products dimension, I have a dimension already and color is available for accessing. So this is good to go. Okay. Now, what is the next thing? I want count of star. What count of star? Count of star of dim product, right? Now, dim product will be my fact table. Let me add the measure group dim product. Right click. I'm adding a measure and my measure group table is dim product. And it is showing all the integer columns. Where is my count? Can you see the count? So the count will be in usage. You have so many aggregate functions here. If by default it will be sum. Okay. By default, generally people want to see sum of the sales, sum of the runs, sum of the units sold. Everything will be sum most of the cases in analysis part. So by default it will be sum. You can go for count of rows, count of non-empty values. How many values are non-empty? Even you can get that. What is the minimum value in that column? If you select any column. If I select this, then I have to select any one column here. Then it will give you the minimum value. Okay. I'll add a couple of measures and I'll show you how each one differs, how each one shows. Okay. First, I'm taking count. Let me take sum. You know very well what sum will do. Count. If I select count, everything will be disabled. Why? Because it's count of rows. You don't need to select a column. Count will be for the complete row, not for a complete single field, single column or single cell. Generally, if you write a count statement, select count of star from a table, it will check for how many rows are there, right? Not how many fields or how many cells are there, right? So that is why all the columns will be disabled. Now I have created count. Now let me create a couple of other things. Count of non-empty values. Generally, you will not have non-empty values for that. So let me select some column which is having empty values. Let's say size list price. I think list price will not be there for most of the things. Non-empty. I'll rename it as non-empty list price count. And let me take another aggregate function that is minimum. What is the minimum safety stock level? Okay. And let me take another one, maximum. Okay. And now let me take another one, distinct count of, let's say, color. This color column. Okay, distinct count, it will go for a new one. I'll tell you why. Let me take another one from bottom somewhere. First value. What is the first value that is present in the table? And I'm gonna select last value too. What is the last value that is present in the table? And what is the first value, last value we have taken, and first non-empty. Let's see what is the first non-empty for the list price and what is the last non-empty value for the list price. So if you observe, what I'm doing here is I'm trying to show you different aggregate functions. Okay, what are all the different aggregate functions that are available that you can use instead of blindly going for some always. Let me show you how you can do that. Now if you see, something is semi-additive measure. 1 second, let me take minimum safety stock. No, this is fine. First list price, last product key. Okay. One second, guys. There is an error. Let me correct it. So in short, instead of taking sum, I have taken different aggregate functions that are available for using in SSAS cube creation. So let me close this. This is processed successfully, and let me go to the browser and let me drag count first from dim product. There are total 606 records in the table. If you have any queries, you can check it. I'll write a query for that. Select count of star from dim product. You can see 606 records are there. Now I'm going to products dimension and I'm dragging English product name. Every product name is unique, right? Here it will be only once. Agree? Agree with the value here? Every product name will be only once. But if you see AWC logo cap, it is showing the count as 3. Let's check why it is. See, this is a product table and each product will be only once. In a customer table, customer name will be only once. But why this product AWC logo cap is showing thrice? Let's check that. To check the same, what we have to do is write a query to pull how many are there. Select star from dim product where English product name is equal to AWC logo cap. It has 3 records in the database and all the 3 has different product keys. That is why it is showing 3 as count. So that's the mistake in the database. Now let me drag color into this. You can see color wise grouping has been done. This color, these are all the products. Okay. Now let me take this color out and let me show you how the different measures, whatever we created using different aggregate functions work. Product key count. What is this count? What is this count we have given? Non-empty records, right? How many non-empty records? Non-empty values for the product key. There will be no empty, no null value for the product key. So this is perfect. And this is minimum value and this is maximum value. And if you see, this is subcategory name, subcategory key. This is the minimum value. It will be very worth, it will be very good if you remove this and check based on some other attribute which groups the data. Here if you see, the minimum value for in black color products is 31. In blue color products is also the minimum value of the subcategory is 31. For gray, it is 35. In the same way for black, it is 0. Sorry, maximum and minimum you can see, right? So I'll explain you how it will show the data. Here if you take this max of product subcategory key, I'm taking max of product subcategory key. This is the maximum value that is available in the in this particular table. Now group by, if you group by English product name, what will happen is for every product it will take the max and min. Okay. If you group by color, then it will give color wise max and min. Every color will have some subcategory values, right? Some, let's say 100 subcategory IDs. So from that it will take the maximum value. Black color, let's say it has some, I'll show you here. This is black color, right? I'm dragging product subcategory key into this query and you can see all the queries will be here. 33, 6, 25, and 31. These are the subcategories that comes in blue color. And I ask for maximum value for this. Maximum value is 31. It is showing perfectly, right? And minimum value is 3. It is showing perfectly. If I minimize it, you can see it clearly. 31 and 3. In the same way, black, if you see, there is blank value which is showing as 0 and maximum value is 31. And multi, if you see, it is minimum is 18 and maximum is 21. 21 and 18. Is it not working perfectly as expected? And let's see white color. White has only 23 and hence the maximum and minimum both is the same. So what it will do is it will group the data and it will group and that it will try to get the maximum and minimum. If I remove this, there will be distinct records. For every record it is the maximum and it is the minimum. There is no other group available here. Now if I get English product name under this, so this product subcategory has all these products, right? So this is how you can make use of different aggregate functions that are available in SSAS. Now if you come to the topic, this is fact relationship, right? The dimension and the measure group are created using the same table. This is fact relationship. And let's see how to set the fact relationship. Fact relationship automatically it will set. If you see, nothing to select. If you just select as fact, automatically everything will be taken. You don't need to do anything. Generally it will be like this, right? Basically it will be no relationship, right? If you go and select fact, then automatically it will be selected. Why? Because it knows this is the fact table and this is the dimension table, and the common column in the same table, it's known fact, right? So that is why the fact relationship automatically it will be taken if you create a dimension using some table, and if you use the same table for creating the measure group, the fact relationship will be automatically set to the SSAS, set in the SSAS dimension usage. Let's say this is your dimension table, and if this is your fact table, then you have to tell what is the common column between these two, right? If this is your dimension table and the same is your fact table, do you need to tell what is the common column in that? What is the primary key column in that? You don't need to tell that. So that is why in fact relationship automatically it will take. The only thing you have to do is you have to select the relationship type fact. So then it will go and get the dimension table, check the dimension table, and it will go and get the other table, fact table, and it will come with the complete design like this. Now what will happen if I try to give fact relationship for this? Will it accept? If I select the fact relationship for fact internet sales to products, it is not showing anything. Why? Because the tables are not same. Understood? If the tables are same, then only the fact relationship can be set. So if you select fact, it will go and check. First thing that it will go and check is whether the dimension table and the fact table is same or not. If it is same, then blindly it will pull the data and it will show. Everything is disabled. You cannot modify anything for the fact relationship properties. Now we have seen how to give. We have seen three types. One is when master table and the fact transaction table. Let's forget about master table and transaction table terminology. Let's talk about dimension and facts from measure groups from here onwards. Okay. When the master table and the measure group table are not having relationships, then what relationship you will give? The relationship is no relationship. Okay. When the dimension table and the fact table are directly related, then what relationship will give? It will be regular. When the dimension table and the fact table, measure group table are same, then what relationship? It's fact relationship. Now we are fine up to here. Let's say this is your transaction, the first one. Sorry, that is measure group, and this is your dimension. And I have one more dimension. It is related in this fashion. Then what relationship you can give? Now I want to relate this dimension with this measure group table. What relationship I can give to set this kind of relation? It will be reference relationship. This guy is relating to this measure group using the reference, using the intermediate dimension. It is using the dimension which is in the middle as the reference one. Okay, reference, it's a pure English, right? Let's say this is Rupesh and this is you. Okay, and this is your friend who referred you to me for trainings, right? So this acts as reference in the middle. If this is not there, then this guy is not related to this, correct? So the same way, the dimensions, if the tables, if the SQLs are, if the database tables are in this fashion, when this is transaction, it is directly joined to some master. This is direct regular relationship. And if there is any master table which is not directly related to transaction but related through some other master table, then this kind of relationship is called as reference relationship in SSAS terminology. What if I have one more master, okay, and this is related to this? How can I set this? Can I set reference relationship, or I can go for any other type? It is reference of reference. That's a good answer. So let me show you how to set the reference relationship and what is the prerequisites. If I want to demonstrate reference relationship here, what needs to be available? The first and foremost, first let me remove the unwanted stuff from the dimension, what is that, products, and then you just guide me. I'll follow your steps. Our target is to create a reference relationship. Let me remove all the unwanted columns here. This is primary key column, I need it. Okay, now tell me, what is the first step I have to do to demonstrate reference relationship? You know very well, reference relationship means it's referring through some other master table. So which table is having such kind of relationship here? Let me arrange the tables. Can you see and tell? I'll do one thing, I'll zoom it, I'll make it 75% so that you can see the complete table list. Which table can be used to demonstrate a reference relationship here? Dim customer by Shiva, and any other answers? So many answers, couple of answers are correct, couple of answers are very horrible. Okay, so if you observe here, can't you see, I mean, are you blind whether the tables are directly related to the fact table or indirectly related? First question to the people who said it's dim customer. How this dim customer is related to your fact table? It is directly related. And to the people who said promotion, how these two are related? And how currency, somebody said currency, how this currency is related to your fact table? And I told you clearly, when you have a star schema, this is a star schema. When you have star schema, then you cannot set any other relationship apart from regular or fact relationship. Now, to demonstrate the same, what I have to do? To demonstrate the reference relationship, first I have to add some table which is not directly related but related through some other table. Okay, let me take that. How can I get that? One way, by using add relationships. Okay, and let me remove the junk also. You are getting confused if you have more tables. Let me remove the junk. Dim time. Okay, I have only fact internet sales and dim product. If I select this dim product and click on add related tables, I'll get all the related tables here, right? I'm taking dim product subcategory. How this dim product subcategory is related to packed internet sales? Let's see that. So if I arrange the tables, this is packed internet sales, this is dim product, and this is dim product subcategory. I have to set the relationship. Let me zoom it. Okay. And this product key, you know, it will be joined to the fact internet sales. I removed the relationship, that's why it is not showing. From here, where is the product key? Now if you see these tables, this 3 table structure, this is directly related to dim product. So this is regular relationship. And how dim product subcategory is related to fact internet sales? This is indirectly related, just like the diagram I have shown, right? That I have drawn a diagram, right? Just like that. This is related to this. Sorry. This is related to this through this guy. If the intermediate one is not available, then gone case. You cannot join this product subcategory to fact internet sales. First, let's see how to define the SQL query for this, and then we can go for SSAS task. Select star from fact internet sales. Oops, I'm not able to type anything. Select star from fact internet sales. A, inner join dim product. B, on A dot product key is equal to B dot product key. Right? Now my intention is to join subcategory which is not directly related to fact internet sales but related to fact internet sales through dim product. So how it will be? One more inner join dim product subcategory, I'll name it as C, on B dot, that is product dot product subcategory key is equal to this dot product subcategory key. So this is how you give relationships in SQL Server. If the tables are, more than 2, and if they are having common columns, then this is how it will go. The chain will go like this. Now, what you see, if you observe, if I don't have this intermediate table, let's assume I don't have dim product table, then I cannot join this dim product subcategory to fact internet sales at all. That is acting as bridge between these two. Bridge between the fact internet sales and the dim product subcategory, or in other words, it is acting as reference between these two. So now let me explain you how these reference kind of relationships will be set. The first and foremost thing you have to do, you have to think about is the data source view, whether you have all the tables that are required for the data source, for creating reference relationship like this. The second thing is whether the dimensions are created. I have created product, but I have to create subcategory, right? There is no subcategory dimension created. So let me select the subcategory one, click on next. I'll select English product subcategory name, click on next. I'll take it as product subcategory. Now the dimensions are ready, and also the measure group is also ready. I have fact internet sales already. So let me, then what I have to do is I have to add the dimension newly created, that is product subcategory, and it is ready, available now. What is the next step here? I have to give the foreign key relationship. I have to give the relationship between fact internet sales and dim product subcategory. And what I have to use is reference kind of relationship. And the reference dimension is products. Okay. Now go to referenced, and you have to select what is the intermediate dimension, products, and here you have to specify what is the common columns. Product subcategory key is the common column in both, but there is no product subcategory key in my intermediate dimension. What I have to do now? There is no product subcategory key available to join. That means I don't have product subcategory key in this table. Then will it work? If I don't have product subcategory key in the dim product table, it won't work. So what the problem here is, in products dimension, I have not included in the attribute list. So let me include it. Now let me go back here. Let me go to the reference relationship again, and let me select the intermediate dimension, that is products, and the relationship between this products table and the subcategory table is through product subcategory, and I am not specifying any relationship directly with the fact and the net sales. How it works is, it will go here, it will take the join to the products, so it will go and join with this, and here it will come and join with the fact and the net sales. This is how the querying will be done when you process the cube and browse the cube. So first it will go to the subcategory, and it will go to the products, and it will join the products, and then it will go to the fact and the net sales, it will join the fact and the net sales, and it will give you the data. So this is how the reference relationship can be set. The setting of a relationship is not a big problem here. The problem is understanding when you have to go for reference, when you have to go for regular, and when you have to go for fact and many to many. Now let me go to the next step. One more step with the reference relationship. Okay. Before going to that, let's say I have not given any relationships. Let me set it to no relationship. Okay. There is no relationship between product and fact and net sales, and product subcategory and fact and net sales. Now, if I try to set the relationship as referenced using the intermediate dimension, it is not showing anything. Why? Why? Because there is no dimension which is having relationship with the facts and can be used as the reference in the product subcategory. Now, if I set the relationship for this first, sorry, it should be regular, right? If I set the relationship for this first, then it will start showing this particular dimension in the reference relationship or intermediate dimensions option. So this is how, keep in mind, this is just like joining of tables, but using wizard. You are setting the joining part of the table between product and subcategory. That means this join part you will give in reference. And what about the remaining? That will be covered as part of the first one, right? So this is about reference relationship, and let me add one more table to demonstrate the reference, one more example. So now I'm going for the tables which are related with this. So there is product subcategory which is related. If you see, this product subcategory is related to fact and net sales through dim product subcategory and also through dim product. Now to add this, first let me create a dimension using the dim product category table. Click on next. English product category name I am taking. Okay, and I'll name it as product category. Finish. And you all know that I need product category to join with this product category, right? In subcategory dimension, there will be a common column with product category, right? I have to maintain that attribute, or else it will, I'll face the same problem which I have faced while giving the reference relationship for product category. Now let me add the dimension to this cube product category, and now it is ready to give referenced. What is intermediate dimension for this? The intermediate dimension is product subcategory, and these two are joined using product category option. This is fine. Now, if you see here, dim product is the fact table. That means, where is that? Dim product is the fact table. That means this is my fact table, and what this guy will become to that fact table. Is it regular or referenced? If this is your measure group table and this is your dimension, how these two will be related? Is it reference relationship or regular relationship? It will be regular. So that is why, if you see here, this is fact relationship set, first one, and the second one, product subcategory to product dim product, it is regular relationship set. You can see regular and the common columns. Now if you try to give the relationship between product category to dim product, it will be referenced through product subcategory. I hope you understood now what is this reference relationship and regular relationship. And if you go back to this image, what I have given now is relationship between this guy and this guy, this fact table. So it will be referenced through this product subcategory table. That is what I have defined there. So this is about the 4 types of relationships, and the next one is many to many. Before going to that, let me know if you have any questions. I'll give you 5 minutes time for questionnaire. Good that you don't have any questions. Now we are gonna see the last relationship of SSAS that we are gonna discuss, that is many to many. First of all, many to many relationship, we need to have data, and for that let me explain in Excel sheet first, and then we can go to the designing of tables and whatever it may be. I mean, if possible in this session, or else we will continue in the next session. First, I would like to explain the many-to-many relationship properly. Why? Because if you have to design the database, then this is the most trickiest one. I'll take cricket. How many of you know cricket? Better to ask like this. How many of you don't know cricket? Okay, a couple of you guys don't know cricket. So let me take some other example. Which one I can take? Let's go with the example given by Divya. That is TV, dish, something, right? That's a little bit confusing. Tell me some example where the main relationship will be many to many, so that I can explain you that. Let's take movie and cast. That is fine, right? Let's say I have movies and I want to see which movie, which hero, or how many heroes. There may be multi-starrer movies and so on, right? So that will be many to many. One hero will be in many movies, and one movie will have many heroes. Agree? First, I will create a table for heroes list. Hero ID. This is one dummy example, but I am not getting any other right now. Second one is hero name, and you can go for his language and so on. Couple of other information. Whatever will come, that's dependent on this hero ID, right? This, on the primary key column. So it's not mandatory to discuss all this stuff now. Let's say the hero ID, or better I'll say actor ID. Okay, actor ID, actor, and language. Let's say 3. Actor ID 1. I'll use your names, Nisha, and language is Hindi. Okay, and what is the next? Second, let's say Paul. I'll go with Hindi. 3, Kalaivanan, Tamil. 4, Vikram, Tamil. 5, Ravi, Telugu. 6, Pratik, Telugu. 7, Samyukta, Telugu. 8, Divya Bharatanatyam, Malayalam. Okay, and I missed some names, right? Let me see what. Kranti, yeah. 9, Kranti, let's say Malayalam. And who is missed? Veerappan Samyukta, Shiva. Let me cover Shiva also. Shiva, Konkini. Okay, these are the actors we have, and let me take a couple of movies. Movie ID, actor and actress, that is fine. In general, the best female actor, something like that. I mean, actor is the general one, I think. So, okay, fine, take it easy. You can maintain a separate table with actress and actor. That is different. Okay, I'll do one thing. What we can call actor or actress. I'll say Nisha is 1, 2, 2, 2, 2, 2, 1, 1, 1, 2. I have a separate master table, act ID, actor or actress. Okay, 1 is actress, 2 is actor. Is it fine? Okay, now 1 means you can join these two tables to find out whether the actor is an actress or actor. Okay. Now movie ID, movie name. So let's say first movie, SSAS training. Second, MDX training. Third, MSBA training. 4, SSIS training. 5, SSRS training. So all these are flop movies. Okay. So I have 5 movies here. 1, 2, 3, 4, 5 SSAS, MJX, MSBA, SSIS and SSRS. Now, you have to give many-to-many relationship. Many-to-many relationship in the sense, let's say this movie would have 3 actors, 1, 2 and 3. And this actor also acted in couple of other movies. Right? So this is called many-to-many relationship. In one-to-many relationship, what we will do? If you take one-to-many relationship, it will be like employee ID in your master table and employee name also in your master table, and leave ID will be there, and here you will maintain employee ID. Why? Because one leave can be taken by only one employee. This is one-to-many. You can use employee ID n number of times here, right? So this is how one-to-many relationship. The ID, the primary key ID will be available in the transaction table. But this is a different story, many-to-many. Where you are going to set? Are you going to pull this actor ID into the movies table or movie ID into the actor table? How you are going to maintain this? So if you take either of the way, it will not work for you. Why? Because if I take, let's say I have taken actor ID to this. In SSAS, I can have only one actor ID here. I cannot have more than one actor ID, right? Why? Because this is a master table. The data should not be duplicated. And if I take a movie ID into this actors table, then one actor can be having only one movie ID. So it won't be, we can't set that relationship. So what we have to do is we have to maintain a separate table, or there is one more way, that is movie ID, name and actor ID, and forget this table as master table. Don't use this table as master table. If you don't use this master, that means you are going to get this SSAS training many times. Let's say SSAS training is the movie and actor ID is 1. Nisha acted in that. Now, one more actor acted in the same. So, again 1, SSAS training, actor is, let's say Divya Bharatanatyam. I'll go for 8. And next one, movie 2, MDX training, actor is Vikram. So ID is 4. In the same, there is one more actor, Paul, 2. And in the same, we have Nisha also acted in that. Now the third movie, MSBA training, actor is Paul, 3 MSBI training, sorry, and actor is Shiva, and 3 MSBI training, actor is Kranti 2. And the fourth movie, SSAS training, actor is Samyukta. Again the fourth movie, SSIS training, actor is Ravi. And fourth movie, SSIS training, actor is, which one is missing? Pratik. And any other name? Kalaivanan is missing. So this guy also acted in this movie. Okay. Now, if you have data like this, you can maintain data like this. Movie ID will be repeated, movie name will be repeated n number of times. It depends on how many actors acted in that movie. Let's say the first movie acted, only 2 actors acted in that, so 2 times repeated. The second movie, 3 actors, so 3 times repeated. Third movie, 3 actors, so 3 times repeated. Fourth movie, 4 times, so 4 actors, so 4 times repeated. If you observe, there is one problem in maintaining the data like this. The problem is this table will not become your master table, and it will not be fit. It will be very you cannot use this as dimension table. Correct? So what we can do here is, instead of using the name of the movie, okay, remove the name. I'm removing the name from here. I will use only movie ID and actor ID in this table, and I will still maintain this movie table here. So one extra table came into picture with only the ID, the combination. In short, I can say with the combinations, with the combination of this and combination of this. If you go for product to a customer, let's say this is customer 1, product 1, customer 1, product 2. Now customer 2, product 4, customer 2, product 2, customer 2, product 1. So you can map any kind of many-to-many relationship if you have a bridge table like this. This bridge table will have IDs from the first master table, IDs from the second master table, and also nothing else. It will just have the mapping, what kind of mapping it has been, which customer, which product, or which actor, which movie. Right? Now, people will question how you will join this, how you will get the data. So the joining will be like this. This actor will be joined with this table, and using this movie ID, you will join to this movie table. So joins are set. Where you are going to maintain the fact data then? The fact data will be maintained in a separate table. Let's say here, ID, okay, movie ID, and collections. Now let's say movie ID is 1, ID is 1, movie ID is 1, collections is just $100. Movie ID 2, sorry, ID 2, movie 2, $200. 3, $10. 4, $1,000. Let's say you will maintain the fact data in a separate table. Now, let me show you how the tables will be related. If I want to see movie-wise sales, I will join these two directly. Correct? I'll get the sales directly. SSAS training, it is $100. MDX training, it is $200. MSBA training, it is $100. SSAS, it is $1,000. And SSRS, no one is there. No collections. Now, if you ask me the same, how much collections was made by Nisha? So what I will do is, I'll take the Nisha ID here, that is 1. I'll join with this table for actor ID. So Nisha acted in the movie ID 1, and also movie ID 2, and also let me see whether there is anything else she acted in. Yeah, only 2. She acted in 2 movies. So I will take the IDs from here. So Nisha acted in 2. So I'll take this movie ID 1, movie ID 2. I'll go on join here. So the movies are 1 and 2. So again from here, I'll go here and get the sales of 1 and 2. That is 100 plus 200, $300. So the collections for the movie acted by Nisha is $300. And if you check similarly for Paul, it will be like Paul ID is 2. Here 2 is available for the movie 2 as well as 3. That means 200 plus 100, it is $300. So this is how. And if you see here, this is your fact table. Good. This is one dimension table. Good. This is another dimension table. Good. Between if this is not there in the middle, this relationship will become regular reference relationship. But this is called as bridge table between two dimensions, or in other words, we call it as factless fact table. I told you there are three types of tables. One is dimension, another one is fact, third one is factless fact table. So this is your fact table, this is your dimension table, this is your dimension table, and this is called factless fact table. Means this acts as a fact table, but it will not have any facts. Facts means measures. No metric values will be available here. It is just acts as a bridge between two dimensions. And if I'll show you the same in SSAS, then you will get clear picture. If you go to the relationship type fact many to many, you can see this is your original fact. Okay, let me erase the drawings. This is your original fact where you will have collection information, and this is the dimension which is having direct relationship, let's say movies in our case, and this is the factless fact table which is having relationship to movies through movie ID, and this is our dimension table which is having actors information and also joining with the factless fact table, and this guy is called as factless fact table. Is it clear? The bridge table here is neither master nor transaction. It will not have metrics, so it is not transaction, and it will not have primary key column, so it is not master. So it acts as a just bridge between two tables, and that is why the name, it is neither fact table nor dimension table. It is factless fact table. It's a fact table but without matrix. Okay, and here if you see, we discussed one example, right? From that, if you apply the same example for this image, then it will be very clear. This is for you, Samyukta. This is your collections table where you have collection information, right? Yeah, here it is. This table where you have collections is this one, right? Now this dimension table is the one which is having direct relationship to the collections table, that is fact table, that is this table. Okay, and the third one is factless fact table. This will be joining to the movies through movie ID. That means this is the joining part, and this is the table, factless fact table. And the fourth one is this factless fact table again will have dimension relationship. So that means from actor to actor. Why this is required? Why this kind of complex means just to meet many to many relationship. If you take fact relationship, and if you take regular relationship, and if you take fact relationship, it is nothing but one-to-one relationship. The same primary key column based, it's joining. If you take regular and reference, regular it is one-to-many, and if it is referenced, it is again one-to-many. But this is many-to-many relationship. That is why the name itself says many-to-many relationship. And to maintain data in a many-to-many way, you need a bridge table, and this is the bridge table, and we call it as factless fact table in SSAS terminology. And this is up to this session, and in next session I'm gonna demonstrate you how to give many-to-many relationship in SSAS. After that, we have to speed up. Why? Because we planned for 15 sessions, and it may not get over in 15 sessions. I'm afraid, I'm scared to say that. Okay. So that's it for today's session. And if you have any questions, you can ask now. Else we can sign off, and we will catch in next session. Okay then guys, catch you in next session. Bye bye.